Okay, let's talk about a factoring technique called grouping. Um, First of all, when should we factor by grouping? One indication that you're going to do that is the existence of four terms in the expression. Okay, so this polynomial has four terms. We typically see the exponents going in descending degree here, right? This is x to the first. This is really x to the zero power, okay? So one thing when it comes to grouping, what we look at is the difference in these exponents. The first two in order would be cubed and squared here. The difference there is one, and then we would need to see a similar difference here in these exponents. So the difference between one and zero is one as well. Okay, now obviously we're not going to write this, but we need to see that difference being the same. So we have four terms. We have the difference in the exponents being the same here and here. And so this concept of grouping, it looks a little odd at first. And we'll talk about the procedure and then we'll talk about why it works. Okay, it's kind of an interesting an interesting method here. The grouping part of this is taking the first two terms and sort of closing them off and closing these off, right? Now I'm putting these parentheses in here. This doesn't mean that these are being multiplied, but this is what I'm using as the first group. This is what I'm using as the second group, okay? And so when you factor by grouping, you look at the first group and you try to factor out the greatest common factor here. So what we've got three x's here, we've got two x's here. So in both of these terms, they have x squared, which leaves me with an x here. When I factor x squared away from here, I still have a minus 6. Now I'm going to leave a space here and I go to the second group. Now, in order for an expression like this to even be factorable by grouping, what we need to do is we need to be able to come up with this same binomial from this group. In other words, I need to be able to factor something away from these two terms that would result in x minus 6 being this binomial. So when you look at positive 2x, and notice I kept the symbol, the plus symbol with this term, that's key here. What would I have to factor away from positive 2x to end up with just x, right? And we would obviously, I hope it's obvious here, we'd have to factor out a 2, and that would be a positive 2, right? I know it's a bit awkward to write that plus sign there, but that's what we would factor away from 2x to be left with an x. Now, if I'm factoring a 2 away from here, does factoring a 2 away from 12 leave me with 6 or a negative 6, if you want to call it that? It does. Okay, now if this was let's say this was a 13. If this was a 13, I wouldn't be able to factor a 2 away from here and here to the outside and end up with a 6. If this was a 13, 13 divided by 2 is not 6, right? So the bottom line is this binomial and this binomial need to match. So once you've figured out what's going to get factored away from the first group and the binomial that results from that, you might as well just write that binomial here and say, okay, now I need to take something away from this group to end up with that binomial. Okay. Now, where we go from here is a bit odd. And again, we'll explain how and why this works here in a second. But after we do this, all right, let's see if I'm going to color code this here. We take the two pieces, the two factors that were taken out of each respective group, and we put them in their own binomial. So the x squared and the positive 2, right? So that's why the plus sign was important to have there. So we take the x squared, we take the positive 2, they get put in their own binomial, okay? And then this is where things get kind of weird. We take this binomial, the x minus 6, they have to match, they have to be exactly the same. And we write that binomial one time. We don't write it twice, even though there are two of these, okay? So this is, and after you get to this point, you're going to want to check because more than likely you're going to have a binomial here that might be able to be factored as well. So just take a quick peek. Now this is x squared plus 2, this is a prime expression here. This can't be factored into real numbers. And x minus 6 obviously is as simple as that's going to get. There's no common factor to pull from here. So this would be our finished product for these two factors. Okay, I'm going to record another video right after this that explains, why this process works. This is the process of how to factor by grouping and when you should factor by grouping. I'm gonna piggyback this with another video here in a second.